let's get going for today. I want to do this question to start off. I want you guys to try and take what you know from class and rewrite this from exponential form into root form. So there's 4 things, and I want you to try and rewrite them. Instead of writing, I'll do the first one for you. Instead of writing 3 to the power of a half, you're going to write the square root of 3 to the power of 1. Now see if you can fill in the next 3 there. Okay. So let's see if we know how to go. Who wants to have a go at doing the first one for us today? Who wants to try and do, how do I write 13 to the power of 3/4 in root form? You can put your hand up if you're feeling like you've got this, and you can just tell me what I need to do. So who feels like they can do this one? Or put a tip in the chat. I think there's something important about this 4 number over here. Where does it need to go? I think for this one, what I need to do is I need to put that like that, and then where does the 4 go? The 4 actually goes outside. Yep, exactly. Oh, so I think someone by mistake pressed a squiggly thing there, no problem. So it's like that. Okay, so I've done the first one and the second one. See if you can do the third and the 4th one. You can put your answer in the chat, or you can yeah. No problem, appreciate. Not a problem at all. So we'll just leave it like that for now, Nicole. So let's have a go here. So we are going to write this as, we look at the 5, the 3 stays in here, and then this goes like that. So this is called changing from power form into root form. And it's just a little skill we want to master. So let's see for the last one. Now, the negative can't attach to the 2. It has to attach to the 3. So another way of writing this would be, I want you to try and write this in root form and say done when you are done. So what are we going to get? Well, again, the 2, let's have a look. The 2 is going to go up to the top, and we are going to get x to the minus 3 to the power of 2. And that's it. So give me a thumbs up if you understand how to go from powers to root form. Give me a thumbs down if you feel not so confident yet and you want to do more examples. I just want to get a feel for the needs of the group. Because we can do more examples if we need to. It's not a problem, but I just want to see how we're feeling. Okay. Keep those happy faces or unhappy faces coming. Just want to see how you are doing. Okay. So let's just do one more example. Let's do one more before we go. So I want to, let me make one up. If I say to you, x to the power of 3/5, can you rewrite that for me in root form? Can you rewrite that for me in root form? And then we're going to move on. So we focus on what's the part that needs to go outside. It is going to be what? What's this going to be? Like that. Now, if you missed the beginning of this lesson, don't worry, because the recording will be available and then you can go over those bits. But let's get started with just some more theory for today. So the law that I was using there, where I was using to help me, is the law of powers and exponents and roots that looks like this, which looks a bit scary. But all we need to remember is if we have root form, the number that's outside just goes to the bottom in the power. And so it's just understanding the connection between that and that. And once you can do that, it's piece of cake. And it says here, to find the root of a power, divide the exponent. So all that you're doing is you're saying, look, whatever exponent there was 2, it's divided by 3, the number in front here. Okay, so that is just a straight conversion. Now we're going to move on to what's called surds. And this is a pretty common part of exponents and surds in terds of learning this topic. So what we have here is, it says, a definition of a surd. A surd is a root of a whole number that produces an irrational number. So when you put the square root of a number into your calculator and it doesn't give you something nice, it gives you something messy, it's going to be a surd. Or if you get the cube root of something and it's not a perfect cube, it's going to give you an irrational number. So it says, therefore, a surd is the root of a number that cannot be determined exactly. And so examples would be like this. So I want you to put these examples in your calculator and tell me, is the answer you get messy or is the answer you get neat? And I want you to say that in the chat. So messy if you get messy numbers for this, neat if you get neat. So I'm looking at the chat and I'm looking to see, are we getting messy or are we getting neat? Now, because one of the things about a surd is that generally when we put it in, well, when we put it on our calculator, it should come out messy, like an irrational number. Okay, what are we getting? I'm waiting for the chat. Messy or neat? Messy, yes, messy. So if you put, and the same with square root 7, like if I said to you, put the following in your calculator. If I told you put square root 4 in your calculator, is that messy or neat? Okay, so Nicole has realized that this is neat, and this means that this square root 4 is not a surd, because the square root of 4 is going to be plus or minus 2. And so that is not a surd, but these ones over here are surds. Okay, now let's go to this. You have to tell me, of the following, of these 5, you have to say whether they are a surd, yes, or they're not a surd, no. So in my chat, I want you to say either yes or no for A, yes or no for C, yes or no for E, and I want you to put that in the chat. Okay. So is square root 53 a surd or not? Yes or no? This is a surd, because if you put in your calculator, you'll see it's going to be messy. What about square root 56? Yes. What about E? No, because the square root of 9 is plus or minus 3. What about G? Is that a surd? Yep. You'll see it's messy in your calculator. And what about the cube root of 121? What about the cube root of 121? What do you get for that? Okay, it's going to be no, huh? It's no, sorry, that is a surd. That is a surd. If I go the cube root of 121, because 5 times 5 times 5 is 125. The square root of 121 is 11, but the cube root of 121 is going to be like 4 point da 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 da. So this is a surd. Yes, this is a surd. So we got confused there because the square root of 121 is it plus or minus 11, and that would not be a surd, but this is a surd here. Okay, I think we've all done enough. Give me a thumbs up if you understand what a surd is, and give me a thumbs down if you don't know what a surd is. I just wanted to check you understood what it means for it to be a surd. Now we're going to move on to surd laws for today. Okay, now, there are some laws that we need to be able to use. They're a little bit, you know, like exponents have their own laws. Well, surds have their own laws as well. And that makes sense because like a root bracket is really just the same as a power in a different way. So how does this work? Well, let's have a look at this. If I think about the square root of 15, I can write that as the square root of 3 times the square root of 5. All right. Or if I want, I can take the square root of 20. So let's zoom into this. And if I think what goes into 20 to make 20, 4 times 5. So I can write this as the square root of 4 times the square root of 5. But I know that the square root of 4 here is going to be 2. And so my final answer is going to be 2 square root 5. Now, this fancy looking algebra over here is just saying that. It's saying, look, in this case, there's a 2 that's here. It's just that when there's a 2 here, we don't write it. But basically, you can take whatever number you have inside the surd and split it into 2 pieces as long as the root or the radical, the root thing is the same. So let's start with an example like this. Let's take the square root of 98. What do you think I'm going to do to split the square root of 98 into pieces? So Buchler has said perfect squares are a good idea. Buchler, you are onto something. Yes, because we know that perfect squares are quite useful because when you square root them, they go to nice, neat little numbers. So why don't you tell me, what do you think I should break square root 98 down into? What do you think we should break square root 98 down into? Okay, Buchler has said 2 times 49. So if I wrote it like this, I could then write it as square root 2 times square root 7, or, sorry, square root 49. Or, you know what, actually, it's probably nicer to write it the other way around, like square root 49 times square root 2. Now, what's that going to end up giving me? Well, the square root of 49 is going to be 7. And then this is just going to stay square root 2 because it is a surd. So the square root of 98 is the same as 7 square root 2. Yeah. So let's have a look at another example. Let's say I want to go with the square root of 50. Can you break the surd square root of 50 down into smaller surds that can simplify it? See if you can do that now. So we're just using law 1 for surds right now. Now, who has put something in the chat here? Who has something for us? Appreciate is off to a good start there. And then so is Noklalo. I think we're going to say this is square root 25 times square root 2. Perfect, Appreciate. Perfect. I knew you did. And then this would be 5 root 2, or 5 square root 2. So all we're doing is we're breaking down a big surd. Now remember, this is a messy number. If I put it on my calculator, it's irrational. And all I'm doing is I'm breaking it down to smaller. And the way I'm doing it is I'm using these perfect squares. But what about if I have something like this? Let's say square root 75 over square root 50. How could we simplify something like that? There's a couple of ways we could do it. I want to see, can you simplify this for me? And there's more than one way I could do this. Okay. I think we can say for 75, square root 25 times square root 3. And what are we going to do on the bottom here? What can we do with the square root 50? Well, didn't we just work that out? And that was square root 25 times square root 2. But now square root 25 is just going to be 5. And 5 over 5 will cancel. And so my final answer is just going to be square root 3 over square root 2. And if I really wanted to combine these into one surd, I could actually just do this as well. But that's using the second law. We don't have to do that. That's making it unnecessarily complicated. But you can do that. Let's move on. Well, actually, let me stop for a moment and ask for questions. Are there any questions or comments or anything that somebody would like to ask? We have a nice small group, so it's a great time to ask questions if you just pop your hand up. Okay. If not, then I'm assuming everyone's doing okay, and we're going to move on to the next one. All right. So I want you to take this, and you're not allowed to use your calculator. And I'm going to do the first one, and then you are going to do the second and third ones for me. Okay, for the first one, I look at this and I see that these all have a square root 3 in them. And what that means is that they're all like terms. So I count, I've got 2 plus 9 is 11. Then I take away 16. So 11 minus 16 is minus 5. Minus 5 plus 6 is 1. So the final answer will just be 1 root 3. Because all of these are related to the root 3. Now, I want you to try and do number 2. Try and do number 2 and try and do number 3 by yourself and see if you can simplify those surds to something using what you know have learned about in surds so far today. So for questions like this, can we use the fishbone method? What's the fishbone method? I don't think I've heard it called that before, but I could just be not have. Can you repeat how we get the root 3? Okay. If you look at this, you've got 2 root 3s. Now you've got 2 apples, let's say, and then you've got 9 apples. The apples aren't apples, they're root 3s, but so we're up to 11. Then we take away 16 of these things, minus 16 root 3, so we're up to minus 5. And then we add 6. So if you add 6 to that, you get 1. And so you get to 1, but then what are the things you've been adding? They're all root 3s. So that's why it's 1 root 3. Ah, yes, Buchle, yes, you can. Yeah. Now, in the second one, it's a bit different because only these two are like terms, right? They both have that. And then over here, we have that. So what are we going to end up with? So there's going to be something root 2, and then there's going to be something root 3, because we know both of the only root 3s and root 2s here. I want to know how many root 2s do I have and how many root 3s. So we have 9 plus 6. So we're going to have 15 root 2s. So 9 root 2 plus 6 root 2. And then 2 root 3 minus 16 root 3 is just going to be minus 14 root 3. Perfect, Naledi. Perfect. Let's see if we can do number 3 now. For number 3, they show you the first bit. They actually show you what the first step is. See if you can get the answer for number 3. I'll give you a minute to do it. Ooh, Buchle is saying that everything cancels out. I haven't got that far yet, Buchle, but I do see that I'm going to get that, and then this is going to be this. Sorry, I'm making things up here. Hold on. 25, and that's 9. Okay, so this is 5 root 3, and this is 3 root 2. So I don't get 0. I get 5 root 3 minus 3 root 2. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't. Oh, what about the other side? Oh, okay. Let's have a look. So we got 25 times 3, and that's, don't we take them over? Oh, no, this is the same thing. So over here, that is equivalent to that. and that is equivalent to that. So we're just having equal signs. But good question, Bukle. Okay, one more question before the break. No problem. That's why we're here. I want to see, can we break down this? And maybe it's easier to write it like this. So if we write it like this, then we can see better. What should we break the 48 down into? What should we break the 48 down into? So let's have a look. 48, I think a perfect square would be, so square root 16 times square root 3. What about the 27? What would that be broken down into? So 27 would just be square root 9 times square root 3. Now the 75 we actually did earlier in this question. What do you think we need to do next? Who would like to give me, Bukle, would you like to give me a bit of some guidance in terms of what you think we need to do next? If you're willing to share. Yeah.
So I'd say
Yeah.
we'd simplify. So because 16 is a perfect square, so we take it out and make it 4.
Okay, so you get
And
4 root 3. Yeah. Oh, hold on. Why is my pen
and then
moving?
plus 3 root 3,
So 4 root
because the 9
3.
we take out as well.
Okay. And then?
And that would be over 5 root 3.
Yeah. Because you can move that 25 to the front. So then 4 plus 3 is 7 root 3 over 5 root 3. Let me write the 7 so it looks a bit better. What do you think my final answer is going to be then? So I think that we're going to cancel that out, and my final answer will just be 7 over 5. Let me know in the chat if you followed that. If you followed that question, then you really are making progress. Let me know if I lost you there, or if you could follow with a happy or unhappy face. And then I think it's time for a break. Let me know, people. How's it going? How's it feeling? I want to know how my students are doing. Have I been going too fast, or have I been going the Goldilocks amount? Okay. So don't be afraid to be honest here. Honesty is the best policy, but let's do some exercise, because we know if we take care of our brains will take care of us. So I want everyone's cameras on. I want to see your faces. I want to feel you with me as we do some exercise. And for those who are not used to this, trust me, you're going to love it. Just give it a chance. Okay, so we're standing up and we are just stretching. Naledi, I want to see your camera on. Kaylee, I want to see you. Babawa, Unoseni, Brukle. Oh, let's stretch. Oh, that feels so good. Oh, it feels good to have a body that moves. Let's do some small circles. Let's do some big circles. Oh, let's do some light twisting from side to side. And, oh, there we go, double click. And let's roll the shoulders. Roll them back. Roll them forward. And then shake out your arms, get some circulation. Shake out your legs. Make sure your body's still there. Check you haven't left anything behind. Okay, now we're going to get heart rates up. So, make sure you're clear. You're not going to whack anything. And we're going to do jumping jacks, and we're going to do 15. So 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 9. We tied here. 10, woo, 11, 12, 13, 14. Come on. It's good to be alive. There we go. Oh, can you feel your heart pumping? Can you feel your heart pumping? Woo! Okay, so now for today's brain break, I have brought you some Angry Birds. Do you guys know what Angry Birds are? Let's do some Angry Birds. Find me how much 3 Angry Birds equal. What do 3 Angry Birds equal? Oh, I appreciate you on the phone. Let's have a look. Okay, so I don't know the answer, appreciate. So are you saying 8? I think for this one, the green Angry Birds have to be 4. But yeah, first one is 4 times 4. I'm with you, Naledi. And then what about the next one? Something divided by something is 3. So like I was thinking 6 divided by 2 or 9 divided by 3. So something, 10 plus something equals 4 plus something. Oh, this is tricky. What do we have? Who feels like they can get it? So 9 plus 4 is 13. 9 and 3. I feel, is 9 and 3, anybody feeling like maybe I'm onto something there? Because if this is 9 and this is 3, 9 plus 4 is 13. 13 minus 3 is 10. But what is 9 divided by 3? It's also 3. So this needs to be 9 and that needs to be 3. So what are my 3 Angry Birds going to be? What are my 3 Angry Birds going to be? They are going to be, so it's plus plus, so it's 16. Yep. So if everybody asks you how much are 3 Angry Birds, you can say they are 16. Okay, cool. So I hope that you have enjoyed your break. Do you feel like the exercise has restored your concentration? Tell me in the chat if you feel like you've been restored, or if you feel in the middle, or do you feel like you've got another 20 minutes in you? No problem. While we're waiting for those emoticons to come running, I want you to try and do these 3 questions using you must just tell your teacher. You can, it's fine. You can just send your teacher a video. Send them a video of our class, and they can do it. Because it's I think all students should be moving their bodies. It's, we take care of your brain takes care of you. That's what you got to do. That's our motto. Okay, let's try and do A, B, and C. So first of all, put the answer for A in the chat. Maybe I should put that on a t-shirt. Hey, take care of your brain so it takes care of you. I quite like it. Okay, square root, squared, absolutely. This is 4, because when the squaring undoes the square rooting. Or another way of seeing this is to say, look, 4 square rooted is actually just 4 to the power of a half. And if you square it, well, 2 times a half is just 4 to the 1. Perfect. What about B and C? Can we get the answers for those? I want you to pop them in the chat there. Now, notice how here there is a 3 and a 3, so they're matching. Now, if I want, I can do this. I can put them all over 3, but then what goes inside? I think, and this is the second law that I was showing earlier on, I get that, but now What is the answer to that? What's the cube root of 8 going to be? That is going to be 2. Yes, Naledi. So thing I want to point out is that the surd laws work for multiplication and for division. You just need to be careful with the division there. Let's try and do C. I want you to think, what can you break these pieces down into? So I'm almost looking for squares, aren't I? Because it's like with all the stuff we've been doing, it's kind of been training me to look for squares. Now, what squares go into, I feel like, anybody with me on that one? Like on the top line? And what would this be? This would be square root 2 times square root 4. Okay, lots of people seem to be saying 6. Now, I haven't quite got there yet, so let's see if I'm on the right track. Now, there's many ways you can get to the answer here, but I was thinking, should I just cancel out one of those? And then what have we got left? Well, on the top, if we want, we can put these back together again. So 3 times 4 is 12, and 12 times 6 is 72. Now, I don't know if all of you are going to like this, but I'm going to do it just because I don't know any other way to do it right now. And then we're going to get, and there's many ways to do this. Oh, look, I do get 6. So that was the one way of doing it. But there's probably other ways. Does anybody else have another way they want to tell us how they did it? They probably did it differently. And we could all benefit from hearing another way. And you just pop your hand up if you feel comfortable. Otherwise, yeah, it's not the only way to get there, but you do need to show the steps. Okay. Well, then let us go on to another one. Can you please do for me? I want you to do A. So please simplify A. And I also want you to simplify C and D. Indeed, you can watch the video. Yes, our lessons are all recorded and they're put on YouTube. And so you absolutely can. And I'll see, maybe I can even get the YouTube link up for you while students are working on that thing there. So we are 11F and our playlist is here. And so I'm going to put the link. So all our lessons, when they have been processed, go. Oh, sorry, I sent it the wrong. I sent it as a direct message, not as a meeting group chat. Let me do that. There we go. And then once you've got the answer for A, C, and D, then I want you to put it in the chat, please. I get 30 for A. Anybody else get 30 for A? Who's on team 30? Put a 30 in the chat if you got 30 for the first for 1A. No, Mkhlamolo, you're on my team. Anybody else get 30 for A? Otherwise, we're moving on to C and to D. Ah, there we go. Lots of people are on team 30. Okay, let's go and do C and D next. Let's see. That would be me using the law of surds for the first part of C. See if you can finish it off and put an answer. So Narco, did you get that for A? Because maybe what happened was you should have got square root 3 times square root 3 is actually going to give you 3. It's one of these weird things where if you have the same number times itself, you end up with the answer like that. So have a look at that. What are we getting as the answer for C? Pleasure, Sanako. Pleasure. That is why I'm here. I'm here to help you. So 5 of these, 3 of these gives me 8. Now, what is my final answer? Well, this cancels, and 8 over 4 is 2. Perfect. Okay, let's do D. Let's do D. What are we going to get for D? $21. I feel like there's nothing perfect about 21. So I'm just going to go with 3 and 7. And then for 60, what can go into 60? I'm just going to go 3 and 20, maybe. But there's no guaranteed right one. And then for 35, I'm going to go square root 7 times square root 5. Now, I can break the 20 down further if I think something would be useful. Oh, of course, 20 can be broken down into 4 and 5. Okay, but I'll give you more time. I want you to try and get me to the answer here. I don't want to steal your thunder. I don't want to rob you of the joy of victory. Let me get rid of some of this. Okay, so I think that square root 3 times square root 3 can be towards the front. So those are those two. And then I'm going to bring square root 7 times square root 7. They can be next to each other. And then I'm going to write 20 as square root 4 times square root 5. And there was already a square root 5 there. Now, what's interesting about surd laws is square root 3 times square root 3 is 3. Square root 7 times square root 7 is 7. Square root 4 is just 2, and square root 5 times square root 5 is just going to be 5. You can kind of see this because square root 5 times square root 5 is just square root 25. And we know the answer is 5. So what is my final answer here? 3 times 7 is 21 times 2 is 42 times 5. It's going to be 210. All right, so what have we done today, ladies and gentlemen? We have learned how to break surds down into pieces, and we've learned how to simplify expressions that have surds. And it really is just about breaking things down into small pieces and then finding a lot of the time we had like square root 3s and square root 2s, and we would add and subtract them. But that's really it. And we will continue in the next lesson with a bit more on surd expressions and then surd equations.